Okay, so today we're going to be talking about parallelograms with our specific type of quadrilateral. Remember, a quadrilateral means that it is a figure that has four sides. Okay, and we're going to talk about the special properties that parallelograms hold. So the two properties about the sides of a parallelogram are that opposites are parallel. Okay, if the opposites are parallel, that's going to give us some special properties about the angles that we're going to talk about next. Okay, also, opposite sides are going to be congruent. So if opposite sides are congruent, that means side AB is congruent to side CD. Okay, it also means that side AC will be congruent to side BD. Again, the only thing you can do with sides, okay, is set them equal to one another. Okay, I'm also going to mark those parallel lines on here. Remember, parallel lines are marked with arrows, just so that we know. Okay, so that would be AC parallel to BD and AB parallel to CD. Now let's look at some examples using those properties. Okay, we're asked to find A and B here. Remember, those that are across from each other are going to be congruent. Okay, so A is going to equal 9 and B will equal 11 here. Okay, because they are across from each other, so therefore they're congruent. You're doing the same process here in example number 2. Okay, find y and x. So you just need to set the appropriate pieces equal to one another. Again, the only thing you can do with sides is set them equal. You just have to set the right pieces together. So if I'm going opposite sides, x plus 2 will equal 4, and then you solve. So subtract 2 from both sides, x will equal 2 there. And then for y, we're going to have y minus 5 equals 12. Add 5 to both sides, and y will equal 17. If you are understanding this, please put a star in the box of these examples. The next set of properties we're going to talk about are their angles. Again, because we have parallel lines, it makes specific angles in the parallelogram congruent to one another. So again, we had said that AC was parallel to BD. And if I were to pick a transversal here, okay, say AB, okay, or CD, I could now put in my X's and O's just like I did with parallel lines, okay, which I'm going to do here. Remember, you can never place an X next to an O. I mean, you can never place an X next to an X or an O next to an O. They have to be alternating. And you'll notice that we have X's and O's within our parallelogram. If you see, our O's are across from each other as well as our X's, okay? And then consecutive angles, right? Consecutive means next to, just in case you need help with that vocab word there, okay? So consecutive is next to. So consecutive angles are supplementary, opposite angles are congruent. So angle B here is congruent to angle C, and angle A is congruent to angle D. Now for consecutive angles, right, that means if they're supplementary, they add up to be 180 degrees. So that's going to be angle B plus angle D equals 180. Okay. Um, angle A plus angle C equals 180. And I want you guys to give me the other two pairs that would add up to be 180. Okay, I'm telling you there are two more, and I want you to make sure you have them on your notes. Okay, and I'll be looking for that when I'm checking for this video. So let's look at some examples. Here, example 3 and 4. Okay, looking at y is here in this corner, in the top left corner, and then we know that 56 is in the bottom right. Notice these are opposite angles because they are diagonally across from each other. So if they are diagonally across from each other, it means that they are congruent. So I'm going to set them equal. Y minus 60 equals 56. I'm going to add 60 to both sides. So I'm going to get y equals 116. Okay, y equals 116 there. Looking at f, okay, these are not diagonally across from each other, right? 72 and f plus 30 are right next to each other. They share the same side, okay? Where the angles that we did in example 3 do not share the same side. These do, so they're going to add up to be 180. So we're going to have f plus 30 plus 72 equals 180 degrees. Okay, and we're going to combine our like terms. So f plus 102 equals 180. And then we're going to subtract 102 from both sides. And we're going to get f to equal 78. Okay, now again, this was the value of f. If we wanted the value of that angle, we would plug it back in. Okay, if we wanted the value of the angle, we would take 78 and plug it back in for f. So we would do 78 plus 30 to figure out what that angle there would be. So we're going to get 108 for that actual angle. Now, sometimes they'll ask you for the angle, sometimes they'll ask you for the value of x or f or whatever letter is missing, okay? The last set of properties that go along with a parallelogram are going to deal with their diagonals, okay? So the diagonals of a parallelogram are going to bisect each other. Remember, bisect means to cut in half. Okay. Which is essentially meaning they're going to split each other in half, right? They're going to cut each other in half. So let me draw in my diagonals here. Okay, and they have now cut each other in half. So if I label this point here in the middle, okay, A to E is going to be congruent to E to D, and C to E is congruent to E to B. They are not equal to each other, okay, but they are equal to the pieces that have been cut in half. Okay, they do not all four pieces equal one another. So here we would have A to E is congruent to E to D, and CE is congruent to EB. Now we do have other special parallelograms that we're going to talk about next class, and they will hold different properties about their diagonals and even their angles at times. Okay, so these are the properties of the diagonals. So let's look at how we'll use this. Okay, so here we are given a parallelogram, and we need to find the values of m and n. So let's start with n, right? N is on the diagonal that starts in the top left corner and goes down to the right. So those pieces are going to be congruent to one another. So I'm going to set them equal. So 9 equals 2n minus 1. And I'm going to solve for n. So plus 1 on both sides. I'm going to get 10 equals 2n. And then I'm going to divide by 2. So n equals 5. So I've solved for n. Now I'm going to solve for m. Okay, the second diagonal there goes from the bottom left to the top right. Again, these pieces are equal. So m plus 8 equals 3m. We're going to subtract m from both sides. So we get 8 equals 2m. Divide by 2. And m equals 4. You do have to have all of these properties memorized. So my suggestion to you is to start making flashcards now so that you can remember them. Please show me these flashcards in class when I see you next. Okay, so let's look at some more concrete examples. It's all going to be about this picture here. So we know that A to D is 20, and we want to know what B to C is. Okay, those are opposite sides. So opposite sides are congruent, right? Okay, opposite sides are congruent. I forgot the word sides there, but opposite sides are congruent, so BC would equal 20. We have DB, so D to B is the diagonal, okay? Then what is DE? So here's DE. So if we know the full diagonal is 22, right, the whole thing is, and we know that they bisect each other, so they cut each other in half, DE is going to be half of 22, which is 11. So there we use the fact that diagonals bisect each other. Okay, diagonals bisect. Let's look at another one. We know that the measure of angle 1 here is 30. So here's angle 1. Okay. Then what is the measure of angle 4? So this is what we're looking for. Remember, we have sides that are parallel. So if our sides are parallel, and we have a transversal cutting them in half, 1 and 3 are going to be alternate interior angles, or 1 and 4 are going to be alternate interior angles. So alternate interior angles are going to be congruent. So this one we used that the sides were parallel, okay? If we know that the measure of ADC, so ADC, this angle here is 115 degrees, then what is the measure of ABC? So here's ABC. Those are opposite angles, so opposite angles will be congruent, okay? And that is the property that we used. Opposite angles are congruent. Okay, notice that I keep listing the properties here because I want to make sure that you are understanding why you're doing what you are doing. Okay, so we have the measure of ADC equals 130 degrees. So ADC again, this time it's 130. Okay, the measure of angle 1 is 35. Then what is the measure of angle 2? So this is a multi-step problem, right? So we know that consecutive angles are going to be supplementary. So we know that angle D here is 130, and we need to find angle C, right? That means they would add up to be 180. And we know part of angle C, so we're going to put X there for angle 2, and I'm going to add everything up to 180. So 130 plus 35 plus x equals 180 degrees. So we're going to simplify there, and we're going to get 165 plus x equals 180. Subtract 165 from both sides. So we get x to equal 15 degrees, so that would be the measure of angle 2. The rest of this I would like you to complete on your own and show me in class or ask me questions in class about the rest of the examples. Again, please ask me any questions you might have when we are practicing in class.